This is really a hard way to live, and our woodpecker friend would never be able to stand it unless Mother Nature had provided him with an effective vibration damping system. A small but soft element between his beak and skull is all that saves him from going nuts. This too is a hard way to make a living. Sometimes parts of the human body are exposed to vibration in our work, something that was not foreseen by Mother Nature. So, our body is not prepared for it. Seeing as most of us use our hands in our work, these of course are the first to suffer. We quite simply have a vibration problem. The blood circulation system in our hands is quite complicated. Our hands radiate heat transported by the flow of blood. Vibration can seriously affect the small blood vessels in our fingers, so that the blood flow becomes restricted. Normally, you might not notice this. However, after just a few years of exposure, the first signs of trouble will start to become noticeable. This is what happens when you go fishing, for example, and you become wet and cold. Your arteries contract to decrease the flow of blood and thus conserve body heat. When the arteries in your fingers become incapable of transporting any blood, your fingers start blanching, and you are experiencing an attack of vibration-induced white fingers. The international standard ISO 5349 gives guidelines for the measurement and assessment of human exposure to hand-transmitted vibration. In the standard is a graph. This axis demonstrates how vibration is expressed in weighted acceleration equivalent to 4 hours exposure per day. Along this axis, we are given exposure times in years before finger blanching occurs. These curves show the percentage of a group of exposed persons that are likely to suffer injury. So, if the equivalent acceleration is 10 meters per second squared, 10% of this group will suffer attacks of blanching fingers after 3 years of exposure, and 50% of the group after 7 years. In a conventional riveting gun, a piston is driven back and forth by compressed air. In its frontal position, it hits the die that upsets the rivet. Reaction forces and shock reflections from the process vibrate the handle of the gun. The outcome from these vibrations can be studied in this sequence from a high-speed film. This is a conventional riveting hammer. Note the surface waves along the forearm. And this is a conventional bucking bar. Here too the effects of vibrations are obvious. A lot of resources have been invested in the development of a vibration-damped riveting system. The design principle is to introduce a soft mass spring system between the gun and the hand. The spring in this new concept is a cushion of air. The mass is the handle itself. The cylinder can move in the handle. When the gun is pressed against a rivet, the cylinder moves back in the handle, pushing a servo piston into the damping volume. The piston lets air into the damping volume and the air pressure increases. The air pressure, multiplied with the servo piston area, balances the feed force. The pressure in the damping volume only changes for differences in feed force. While vibrations are too fast, to change the pressure. From the vibration aspect, the air cushion merely acts as a soft spring. This is an Atlas Copco vibration-damped riveting hammer. It is already operating, and as you can see, the surface waves along the forearm are hardly noticeable. And this is an Atlas Copco vibration-damped bucking bar. Note the motion of the dolly and the lack of motion of the operator's arm. Looking at this frequency analysis, it can clearly be seen that the vibration-reduced riveting hammer has far better values than those of a conventional riveting hammer. Once again, let's take a look at the differences between conventional and vibration-damped tools. This is a conventional hammer, and this is a vibration-damped tool. Here you can clearly see the effects of a conventional bucking bar. And this is the same operation with a vibration-damped bucking bar. Vibration measurement of this new riveting system gives such low readings that if they were converted into exposure dose per day figures, the acceleration figure would end up in the far left of the diagram. So, according to this ISO 5349 standard, you can use Atlas Copco vibration-damped riveting guns for many years. New designs are worthless if they cannot be used in practice. These tools have been very well received among a large number of aerospace customers around the world. And of course, the new bucking bar can be used together with any conventional riveting gun. Modern companies have started to focus interest on high rising costs in the form of critical absenteeism, high workforce turnover, new recruitment training, insurance coverage, injury claims, healthcare, and so forth. All these costs can be reduced by sound investments in ergonomic power tools. Good ergonomics is good economics.